All right, so have you ever thought about what happens when a satellite runs out of gas?
Out of gas.
Yeah, like we could just pull over and refuel, right?
Ah, I see what you're getting at. Yeah, it's not quite as simple in space, is it?
Not at all. Like until somewhat recently, that was basically it. Game over for that satellite.
Yeah, I mean, I can't even imagine the logistics of that. It really makes you appreciate all the work that goes into making these things last as long as they do.
Absolutely. And it's really incredible. NASA actually figured out a way around that.
Oh, tell me more.
It's called the Robotic Refueling Mission, RRM for short.
Okay, RRM, I heard of that. It was all about like developing the tech to actually refuel satellites in orbit, right?
Exactly. And
Yeah.
not just like a little top off, but like full on refueling.
Wow. That sounds unbelievably complex.
Oh, it definitely was. And they didn't just like throw it together overnight. It actually was a multi-phase mission.
I see. So how did they even begin to tackle something like that?
Well, phase one kicked off in style, I have to say. It launched on the very last space shuttle mission, Atlantis, back in 2011.
Oh, wow. Talk about going out with a bang.
Right. And that phase wrapped up successfully a couple years later in 2013. It was really all about proving that this crazy idea could actually work.
So what? They were like sending robots up to tinker with satellites already in orbit?
Well, not exactly. They were using the International Space Station as their base of operations, and they had these mock-ups of satellite parts to practice on.
Ah, okay. A little less risky than working on live satellites, I guess.
Yeah, definitely. And the star of the show was this robotic arm called Dextra.
Dexter. Okay, what's that?
Basically, picture a super dexterous space mechanic.
I like it.
They used Dextra to test out all sorts of new tools and techniques for working with the delicate parts of a satellite's fuel system.
Yeah.
Things like valves and nozzles, that kind of stuff.
I see. Like super delicate work, but in the most extreme environment imaginable.
Exactly. Yeah. And incredibly, they proved that robotic refueling wasn't just some sci-fi fantasy. It could actually be done.
Wow, that's a huge accomplishment. So what came next? Phase two?
You got it. Phase two launched in 2013. And this time, they brought even more sophisticated hardware to the party.
Oh, like what?
Well, they added these things called task boards, basically work surfaces for the robots. Then there was this cool contraption called the RRM on-orbit transfer cage for moving stuff around. And get this, they even had a robotic snake.
Wait, a robotic snake in
Well,
space?
Yep, it was called VDIPR, which stands for Visual Inspection Posable Invertebrate Robot.
That's quite a name.
I know, right? But it makes sense when you think about it. VDIPR is basically a super flexible borescope with a camera on the end. They used it to get a close-up view of the inside of those satellite components.
Ah, so like a space endoscope. Makes sense.
Exactly.
Yeah.
But the real highlight of Phase 2 was the successful transfer of actual rocket fuel from Earth to the ISS.
They beamed up fuel. Really?
It really did. It was nitrogen tetroxide, a pretty common type of rocket fuel.
Wow, that's incredible. So they'd pretty much nailed the basics at that point, right? What was left to tackle in phase three?
Well, Phase 3 was all about pushing the limits even further. It arrived at the ISS in 2018, and their target this time was something even more challenging: cryogenic fuel. Specifically, methane.
Methane. Why methane?
Now, think about where we want to go in space, beyond Earth orbit, deep space missions. Methane is much more efficient for those kinds of journeys, way better than the traditional rocket fuels we've been using.
Ah, so they're thinking long term. That makes sense.
Exactly. And Phase 3 had its share of drama, too. In 2019, they had this major setback when the cryocooler, the thing that keeps the methane super cold, malfunctioned. They actually had to vent all that methane into space.
Oh no, all that work and they lost the fuel? What a nightmare.
It was just definitely a blow. But even with that setback, they still achieved something remarkable. For 4 months before the cryocooler failed, they managed to store that methane with zero boil-off.
Zero boil off. I didn't even realize that was a problem.
It's a huge problem. Keeping cryogenic fuels like methane from evaporating in the vacuum of space is incredibly difficult. So achieving zero boil-off, even for a limited time, was a major breakthrough.
Yeah, I can see how that would be huge. So even though they lost the methane, they still gained valuable knowledge.
Absolutely. And they didn't let that setback stop them. They kept going with other experiments, and in 2020, they completed another round of robotic tool operations using Dextra.
So after all three phases, what was the final verdict? Did RRM prove that robotic refueling is a viable option for the future?
The resounding answer is yes. ROM showed us that we can not only extend the life of our existing satellites, but also open up possibilities for even more ambitious missions further out into our solar system, all thanks to some ingenious engineering And, of course, those incredible robots.
It really does feel like a new era in space exploration.
Absolutely. And this is just the beginning. Our one wasn't just about proving a concept. It was about laying the groundwork for a whole new industry, satellite servicing.
Satellite servicing, so we're talking about more than just refueling.
Oh, much more. Imagine being able to repair satellites in orbit, upgrade their components, even repurpose them for entirely new missions.
Okay, now that's where things start to get really interesting.
Yeah.
So we're not just throwing these satellites away when they have a problem anymore.
Right, like it's no longer a disposable thing.
Yeah, it's more like, I don't know, servicing your car. You keep it running smoothly and it lasts much longer.
Makes sense. And I imagine that saves a ton of money in the long run, right?
Oh, absolutely. I mean, building and launching a satellite, that's incredibly expensive.
I can well imagine.
So if a satellite dies prematurely, it's basically like throwing millions, if not billions of dollars down the drain.
Wow.
Satellite servicing could, like, salvage all that equipment, make space exploration a whole lot more sustainable.
So it's not just about extending the life of what's already up there.
Yeah.
It's about making the whole thing more affordable.
Exactly.
Okay. But I'm sure it's not all smooth sailing. There must be some major challenges with, trying to fix something that's zipping around the Earth at thousands of miles an hour.
Oh, for sure. It's incredibly complex from a technical perspective.
Like what?
Well, you need robots that can, like, operate on their own, at least to some degree, or at least be able to respond quickly and accurately to commands from Earth.
Ah, that makes sense. What else?
And ideally, future satellites should be designed with servicing in mind from the get-go, which wasn't really the case for a lot of the older ones.
So it's not as simple as just sending up, a mechanic with a wrench.
Uh-huh, not quite. But the good news is there are already companies out there tackling these challenges.
Really?
Yeah, and NASA's been working with them too. They're trying to move this technology from, government-led stuff to a more commercially driven model.
So like handing over the reins to the private sector.
Exactly.
So we could see, private space garages popping up?
Who knows? It's definitely a possibility. And it's not just refueling either.
What else is on the table?
Think debris removal, building giant structures in orbit, even manufacturing in space.
Hold on, building things in space. Are we talking like space stations?
Yeah, space stations, telescopes, you name it. And even more ambitious stuff too, like mining asteroids.
Mining asteroids. What for?
Resources. Why haul everything up from Earth when there's a whole bunch of stuff already out there in space?
That's incredible. So we're talking about like a whole space economy opening up.
That's the idea.
But, okay, let's be realistic. What could hold all of this back? Besides the technical stuff, are there other concerns?
Yeah, there are definitely some hurdles. For one, the legal side of things is still pretty murky.
Ah, I hadn't thought about that.
Yeah, we don't really have clear international laws about satellite servicing, so there are questions about, like, who's liable if something goes wrong, what about safety protocols, and even potential military applications.
Oh, I can see how that would be a big one. Like, what's to stop someone from using this technology for, less than peaceful purposes?
Exactly. So there needs to be, like, a lot of international cooperation to figure all that out before satellite servicing can really take off.
That makes sense. So we've got the legal stuff. What about the tech itself? Are there limitations to what robots can actually do in space?
Well, every technology has its limits, right? But the good news is robotics is advancing super fast. Like, stuff that seemed impossible a few years ago is pretty much routine now.
Give me an example.
Well, we're seeing breakthroughs in areas like AI, machine learning, and autonomous navigation.
So the robots are getting smarter and more independent.
That's right. They're learning to deal with unexpected stuff, solve problems on their own, even work together with each other.
Okay, so this is all super cool. But I'm wondering, what does it actually mean for, someone like me who's not a rocket scientist or anything? Like, how does all this impact us down here on Earth?
Well, it might seem like a far-off thing, but it has real-world benefits for everyone.
Like what?
Think about it. Satellite services impact our lives every day.
Give me an example.
GPS, weather forecasting, satellite TV, even internet access. All that relies on satellites working properly.
Ah, yeah, I never really thought about it like that.
So if we can keep those satellites running longer and more efficiently, it benefits everyone.
So no more dropped calls or buffering videos. That's something I can get behind.
Exactly. Plus, it opens up possibilities for space exploration and scientific discovery that we could only dream about before. Like, Imagine being able to refuel and service a spacecraft in orbit so it can travel farther, explore more of our solar system. It could change how we understand the universe.
Okay, now you're really getting me excited. It's starting to sound less like sci-fi and more like, well, science fact. And this is just the beginning, right? There are other projects building on what RRM started.
Oh, yeah, tons. RRM really paved the way.
Like what?
Well, there's the Robotic Servicing of Geosynchronous Satellites program, RSGS for short. It's focused on demonstrating robotic servicing in geosynchronous orbit, which is where a lot of those really important communication satellites live.
RSGS. Okay, I'll try to remember that one. Sounds like they're really going all in on this technology.
Definitely. And there are others too. Space infrastructure servicing is focused on developing tech for in-orbit assembly and manufacturing. And then there's RAFTI, the Rapidly Attachable Fluid Transfer Interface, which is working on standardizing those interfaces for easier fluid transfer.
RAFTI. Okay, that one's easier to remember. So I'm getting a sense of the scope of all this. But
Yeah.
what's next? What are you most excited about in terms of where satellite servicing goes from here?
Well, one area that really gets me going is the potential for in-space manufacturing. Like, imagine using robots and 3D printing to build huge structures, solar power arrays, even habitats in space.
Okay, well, hold on. Are we talking about building entire cities in space now?
Maybe not cities just yet, but the technology is moving fast. And the possibilities, both economic and strategic, are huge. Like, imagine if we could actually use the resources of space. It would be revolutionary.
It's a lot to take in, but definitely exciting to think about. And I have one final question for you before we wrap things up.
Go ahead.
If you could design the next generation of space robots,
Yeah.
what kind of capabilities would you give them? Like, what other problems in space could we solve with robotics?
Ooh, that's a fun one. I mean, just imagine if we could design robots that were like way more intelligent and adaptable and versatile.
Yeah.
The stuff we could do in space would be mind-blowing. We could build like outposts on other planets or mine asteroids or even, I don't know, explore interstellar space. The possibilities are endless, really.
Okay, now you're just showing off.
Yeah.
Building outposts on other planets. That's straight out of Star Trek.
Haha. Yeah, maybe a little bit, but it's not as crazy as it sounds. The technology is getting there, and the potential benefits are enormous. Like, picture a future where humanity isn't just stuck on Earth anymore.
Wow.
We could have settlements on Mars, mines on asteroids, maybe even research stations on the moons of Jupiter and Saturn.
Okay, let's bring it back down to Earth for a second.
Uh-huh.
What about some of the more, immediate problems those robots could help with?
Well, think about the space environment itself. It's brutal, right? Radiation, extreme temperatures, vacuum. It's all super dangerous for both humans and machines.
Right.
So if we could make robots that are more resistant to all that stuff, it would be a game changer.
So tougher robots, more adaptable, maybe even self-repairing.
Exactly. And also, robots that can learn from their experiences, solve problems on their own, work together as a team, and operate more independently without constant input from humans.
So we're talking about a whole robotic revolution in space.
Yeah.
But what about the astronauts? Are the robots going to replace them entirely?
I don't think so, no. It's more about robots and humans working together, like a team. Each brings something different to the table.
Right.
Robots are great for those tasks that are super dangerous or repetitive or require a lot of precision. But humans, we bring creativity, ingenuity, and that ability to think on our feet and adapt to unexpected stuff.
It's not robots versus humans. It's robots and humans working together.
Yeah. Like, imagine a team of astronauts and robots working side by side to build a base on the moon, or scientists using robots to collect samples on Mars. The possibilities are endless when you combine human intelligence with robotic capabilities.
I like that vision. It makes me feel a lot more optimistic about the future of space exploration.
Me too. It's really an exciting time to be alive, and I think we're just at the beginning of a whole new era of space exploration.
Driven by robots.
Driven by innovation and collaboration and a shared sense of wonder.
Nicely said. Well, I think that about wraps up our deep dive into the world of robotic refueling and satellite servicing.
Yeah, it's been quite a journey.
It really has. I've learned so much, and I hope our listeners have too. So a huge thanks to everyone for joining us on the deep dive. We'll catch you next time.